Assalamualaikum and hi everyone. In this lecture video, we are going to discuss about differentiation of simple functions. Here are some basic functions that you must know how to find their derivatives. This formula can be found from your mathematical formula book in page 21 to 24. However, you are strongly suggest to memorize all this formula. Now let us look some examples that may be asked in the assessment. Question A. We need to find the derivative of the function y equals to root 14. For question A, we know that root 14 is just a constant. Whenever you have a constant y equals to c, then dy dx, it is always equal to 0. It doesn't matter whatever the constant c is, then the derivative will be equal to 0. Therefore, for question A, we know that dy dx, it is equal to 0. Question B, we have y equals to x power of 6. And we know that when y equals to x power of n, then dy dx, it is equal to n times x power of n minus 1. Then, since we have x power of 6, where it is in the form of x power of n, where n it is equal to 6, then we know that when y equals to x power of 6, then dy dx, it is equal to 6, which is n times x. So we have n 6 times x power of 6 minus 1, which is 6 times x power of 5. For question C, we have y equals to 3 times tangent x plus ln x. Okay, here we have the constant 3, just remain there for the derivative. Therefore, dy dx, it is equal to 3 times. And we know that when y equals to tangent x, then dy dx, it is equal to secant square x. Therefore, when we have tangent x, when we differentiate tangent x, we get secant square x. And then we have here plus. So plus. When you have y equals to ln x, you know that dy dx, it is equal to 1 over x. Therefore, when we differentiate ln x, we know that we get 1 over x. Next, question E. Okay, I'll erase a solution for A, B, and C. Okay, for question E, we have, for question D, I missed D just now. So for question D, we have y equals to 2x squared minus x squared, where we know that this is 2x squared minus x times 2x squared minus x. And in order to differentiate this function, we have to expand. Therefore, okay, 2x squared times 2x squared is 4x power of 4. And then 2x squared times minus x is minus 2x cubed. And then we have minus x times 2x squared is minus 2x cubed also. And then minus x times minus x is positive x squared. And now we can simplify this because here we have the same term x cubed and x cubed. Therefore, for x power of 4 minus 4x cubed plus x squared. Okay, now you can see that each of these terms, they are in the form of x power of n. Then we can use this formula to differentiate y. So dy dx, it is equal to, here you have the constant 4, just remain it there. And then since this is x power of 4, where it is in the form of x power of n, where n it is equal to 4, then we know that here we will substitute 4. So 4 times x power of 4 minus 1 is 3. And then minus 4. Okay, this 4 remain. And then since this is x power of 3, which is also in the form of x power of n, where n it is equal to 3, then you will substitute 3 here. So times 3, x, 3 minus 1 is 2. And then we have plus, so plus. And then here we have x squared, which is also x power of n, where n it is equal to 2. So we have plus 2 times x. Next, we want to simplify. So 16x cubed minus 12x squared plus 2x. If you want to factor out the common factor, you can do so, where it is equal to, the common factor is 2x. So 2 times 8x squared minus 6x plus 1. Okay. So that is the answer, the final answer for question D. Okay, now we want to move on to question E. For question E, we have y equals to 2 root x minus 5 over x squared. Where we want to rewrite this so that this term will be in the form of this, and this term also will be in the form of this. Therefore, 2x power of 1 over 2 minus 5 times x power of negative 2. Okay, so now we can find the derivative of y, where dy dx, it is equal to, okay, these two remain in the derivative, and then times, okay, here we have x power of n, therefore our n is 1 over 2. So times 1 over 2, x power of 1 over 2 minus 1, and then minus 5. Here we have x power of n, where it is in the form of this, x power of n, where our n, it is equal to negative 2. Therefore, here negative 2 times negative 2. And then x power of negative 2 minus 1. Okay, negative 2 minus 1. Therefore, okay, we can cancel out this. So what's left is x power of negative 1 over 2. And then we have here minus times minus, become positive 10 x power of negative 3. And usually in the final answer, we try to avoid the negative power. Therefore, we will rewrite this as 1 over x power of 1 over 2 plus 10 over x cubed, where this can also be rewritten as 1 over root x plus 10 over x cubed. Alright, next question F. Okay, I'll erase this first. Okay, for question F, we have y equals to x cubed plus 1 over 3x squared. We can rewrite this function as x cubed over 3x squared plus 1 over 3x squared. And this can be further rewritten as 1 over 3x plus 1 over 3 x power of negative 2. Okay. Where now this and this is in this form. Okay. Where for the first one here, x, here we have x power of n, where n here it is equal to 1 because x power of 1 is x. Okay. So here you have 1 times x power of 1 minus 1 is 0. X power of 0 is 1. So 1 times 1, it is equals to 1. Therefore, we have 1 over 3 times 1, which is 1 over 3. Plus this one. So plus the constant remain in the derivative. Sorry, this is supposed to be dy dx. Plus 1 over 3 plus 1 over 3 times where x power of, here we have x power of n, where n is equals to negative 2. So 1 over 3 times negative 2. And then x power of negative 2 minus 1 is negative 3. Where this is equals to 1 over 3 minus 2 over 3 times x power of negative 3. As I said previously, we try to avoid the negative power in the final answer. Therefore, this can be rewritten as 1 over 3 minus 2 over 3 x cubed. Okay, the final example for the topic will be question G. For question G, it is similar to question F, but here we have root x in the denominator. Okay. Where y is equals to 2x cubed minus 4 over root x. Where this can be rewritten, we split into two parts, where 2x cubed over root x minus 4 over root x. And you know that root x is x power of 1 over 2. Therefore, we can rewrite this as 2x cubed over x power of 1 over 2 minus 4 over x power of 1 over 2. And this can be simplified. As 2x power of 3 minus 1 over 2 minus 4x power of negative 1 over 2. Where this is equal to 2x power of 5 over 2. 5 over 2 minus 4 times x power of negative 1 over 2. Okay, now we can find dy dx because this and this already in the form of x power of n. Then dy dx, it is equal to Okay, the constant remain there. And then we have x power of 5 over 2, x power of n, where n is 5 over 2. So 5 over 2 times x power of 5 over 2 minus 1. Therefore, we have 2 times 5 over 2, x power of 5 over 2 minus 1. And then minus the constant 4 remain there, minus 4. And then we have x power of negative 1 over 2, where negative 1 over 2 is our n here. So 4 times negative 1 over 2 times x power of negative 1 over 2 minus 1. Where this is equal to, we can simplify this. Therefore, we have 5x power of 3 over 2. And then we have here minus times minus is plus. So 2 times x power of negative 3 over 2. Where this is equal to 5x power of 3 over 2 plus 2 over x power of 3 over 2. Or you can also write it as 5x power of 3 root x cubed, 5 root x cubed plus 2 root 2x cubed. Alright. So that is the final example. Okay, that's all. Bye-bye.